In this clip, I'll talk about requirements engineering, how to translate requirements into use cases and visualize them using UML use case diagrams. The goal of requirement engineering is to determine what the system is supposed to do. Customers need to be involved in that because they can help you determine what they want. Developers also play a role in requirements engineering to provide the technical boundaries that we need to operate in. Why is it useful to think about requirements? For one, software errors can be very costly. A classic example is NASA's Mars Climate Orbiter spacecraft that was lost in space during its mission to Mars. This happened because a subcontractor developer forgot to convert from English units to metric somewhere in the code. As a result, the 125 million craft came too close to the surface, it plowed into Mars's atmosphere, and all communication was lost. 3 out of 4 software projects fail, and often the reason is either due to poor communication or poor planning. This is why it's important to know what the requirements are. Requirements deal with both the stakeholders and their concerns. A stakeholder is somebody who has an interest in the product and is involved in it in some way. This can be an end user who will actually use the system on a day-by-day basis. It can be a manager that's responsible for maintaining the system once it's deployed, or it can be an advisory board member to the company commissioning the software, and so on. A requirement is defined as a feature that the system must have, or a constraint that it must satisfy in order to be accepted by the client. Requirements engineering is the process of putting together all the requirements of a software system. This is a cyclic process consisting of 4 steps: elicitation, specification, validation, and verification, and negotiation. I'll talk more about those steps later on. There are many different kinds of requirements. Functional requirements talk about actual features of a system. For example, a student should be able to enter their student ID when they submit an assignment. Other kinds of requirements are usability. Online help should be available for all actions in the system. Reliability, the system should be online 99% of the time. Performance, assignment upload should never take more than a minute. And supportability, system upgrades should happen automatically and during nighttime. Other factors can also play a role in requirements, such as which implementation tools to use, how does the license work, and what constraints do other systems impose on us. For example, in an assignment submission system, it makes sense to also look into the Osiris system to find out if there's anything we need to take into account if we want to couple the system with Osiris in the future. Getting requirements is not a simple task at all. So let's look at an example. So this picture looks a bit dated, but the idea still holds. Suppose someone wants to have a remote controlled door for his dog. They want to be able to open the door with the remote from the bedroom so that the dog can go out at night. That doesn't sound very complicated, does it? So the specification is simple. Push the button on the remote to open the door. Push that same button again to close it. So let's make an initial design. We have a dog door class with methods open, close, and is open. We have a remote class that tells the dog door to open and close and that knows when the button is pressed. So here you see a simple dog door class with these 3 methods and a Boolean variable indicating if the door is currently open. And secondly, we have the remote class with the press button method that either opens or closes the door. So let's also write a test programming so we can see how to use these 2 classes and their methods. Oh, here's a few lines of code that tests the system. We create a dog door and a remote, and we press the button a couple of times to see what happens. So we're done. We have established requirements, we have implemented a system that satisfies them, and finally we have tested that the system behaves as expected. Unfortunately, we didn't do a very good job. Our solution was rejected. So what happened? We implemented exactly what the customer told us. Everything works. The problem is that getting the requirements right is not just the responsibility of the customer. You need to make sure you ask the right questions so that you get a complete picture. Customers don't always clearly communicate. So when you continue asking questions, you find out that there's much more to this simple dog door remote problem. And perhaps there are other things that go wrong that the customers didn't even mention. For example, what if the dog barks but doesn't want to go outside? Or the door jams, or the door closes while the dog walks through it. Ouch! Back to the drawing board. Implementing a dog door is really simple. It's basically a Boolean variable with a couple of methods to read it and change it. Figuring out what the customer actually wants is a much harder problem to solve. So how can we do that? This is what the elicitation step in requirements engineering does. You talk to your customer and end users, collect existing documentation, and you observe what users are currently doing. When a customer gives you information, you need to take care to interpret that and make sure that the information you get is precise and complete. Always think about the edge cases that can occur. Most customers only think in terms of the so-called happy flow. The user types their email address and password and then logs in. But what about the other possibilities? The email address may not exist, the password may be wrong, someone might not even type in a password, the network might go down, and so on. There are a variety of elicitation techniques to get to this information. First, you can ask questions. This can be through an interview, a brainstorming session. You can hand out questionnaires among end users if there are a lot of them, and so on. Task analysis is another thing you can think about. What actions does the user need to do, and how are these actions or tasks organized? Which ones belong together? You can also get information by taking a customer through a scenario. How do you currently log in to your system? What happens if you forget to type in your password? Ethnography is another approach where you actively observe what users are doing. This can work really well if it's hard to get specific information from a customer. See what they do and draw your own conclusions. You can perform an analysis of existing documents and software to get an idea of what the main problems are. You can create a prototype and see if this is what the customer has in mind. This actually moves you closer to an agile approach. You can also look at how existing systems solve problems and learn from that. A good set of requirements is correct, consistent, complete, clear, realistic, and verifiable. These are the metrics you can use to determine if you're doing a good job getting the requirements together. Here are some examples of poor requirements. The system should be usable by elderly people. It's not clear what this means and not specific enough. A better requirement would be that all text should be at least in a 14-point font size, or that buttons in the interface should be at least 150 by 50 pixels in size. The system should not have errors. This is very vague and also not realistic. It's better to give specific test criteria, such as code coverage should be at least 80%. Finally, the product shall respond rapidly. It's also not verifiable and not specific enough. Quantify what you want. The system shall respond in less than 2 seconds, or in less than 2 seconds in 99% of the cases. When you collect the requirements, make sure you keep things realistic. Everybody wants a perfect system that's cheap, has no bugs, is always online, is easy to maintain. That's not a realistic expectation. You need to identify what is important and focus on that. If you're using a process such as Scrum, this happens automatically when you organize items in the product backlog by priority. Requirements are a list of minimum functionalities that you promise to deliver. So it's not a wish list. That means you have to make sure you can commit to these requirements. We've seen a number of elicitation techniques in brief. Overall, try different things to see what works. The most important thing is that you gather as much information as possible. The more you know beforehand, the greater the chance that the project will be successful. In order to establish detailed requirements, you can write scenarios and associated use cases. This is similar to user stories in Scrum. You document the system's behavior from the user point of view to clarify how the system helps the user. A scenario is defined as a narrative description, a story that details what people do and how they experience using a system or an application. Here's an example of scenario for someone going to a cash machine and withdrawing money. This scenario describes a single transaction, not everything that could go wrong and how the system should respond in those cases. There are also actors involved in a scenario. Here, the actors are Alice and the bank, and possibly the cash machine, hardware as a system. A use case is more general. It describes an interaction between users and a system that produces some kind of result. You can write use cases at different levels of detail. A brief use case is simply a one-paragraph summary of the main success scenario, similar to what we saw on the previous slide. A casual use case covers various scenarios, including non-successful ones. And finally, a fully dressed use case is a detailed account of all the possible steps and variations that can occur. When we translate the withdrawing money example to a brief use case, we get the following: a few lines of text explaining what the main flow is. A casual use case goes into more detail. What happens if the PIN number is wrong, or the ATM is out of money, or the user doesn't have enough money on his account? And finally, a fully dressed use case has a name, actors, entry conditions, flow of events, exit conditions, and special requirements. Larman's book gives a few examples of a fully dressed use case. For the withdrawing money example, the fully dressed use case has the following description, actors, and entry conditions. Entry conditions specify what needs to be true in order for the interaction to be possible at all. If there's no cash or no network, the ATM should probably display an out of order message. Here's an example of the success scenario, or the happy flow. This describes in detail the steps that occur in the interaction when it is successful. Next to the success scenario, there are alternative flows. For example, perhaps the user's identity cannot be validated, or there is not enough cash in the ATM, or the bank system fails to respond due to a network error. Obviously, lots of other things can go wrong as well. In the fully dressed use case, you need to address all of these. The post conditions or exit conditions map the possible outcome of an interaction. Here, there are two outcomes. Either the customer gets their money or not. Finally, you mention special requirements related to the use case. For example, the ATM should show translated text in all major European languages, or the ATM should keep a log of all activities that occur. So with use cases, it's important to keep in mind that In the end, this is about the experience of the user. Keep text concise and be as clear as possible. You can also draw diagrams to support your use cases. And for this you can use UML use case diagrams. So let's look into that. Here's an example of a use case diagram for withdrawing money. This one is actually pretty simple. The diagram doesn't really add that much information. So here's a slightly more complicated example of a client interacting with a web shop. Here there are two use cases: processing a sale and changing the password. In UML use case diagrams, there are actors, systems, use cases representing particular usages, and arrows that can indicate relationships between use cases. Actors are anyone involved in some way in the system. Even other software systems can be actors themselves. You can organize actors and use cases into system boxes to provide structure. You can also have use cases that reuse other cases. For example, there might be a login use case which is used by other use cases. You can also identify special versions of a particular use case. For example, a generic assign seat use case can be used for assigning both window and aisle seats. Here's another example of a use case diagram, this time for an airline booking system. The customer and the ticket clerk interact in two use cases here: booking tickets and checking in for a flight. When you zoom in on the checking in use case, you see that it actually relies on other use cases as well, such as weighing luggage and assigning a seat. Assigning a seat is again extended by assigning aisle seats and window seats. Now, before we complete this video, I'd like to briefly touch on the last two steps of requirement engineering: verifying the requirements and negotiating them to end up with a sensible set of requirements. Requirements validation checks the requirement documents to make sure it's consistent, complete, and accurate. Verification is a more formal process. It's a possibly automatic mathematical analysis to determine whether the requirements are consistent. Validating requirements means you need to talk to your customers and users and check that you covered everything. Use reviews, checklists, discussions, presentations for this. You can also create prototypes to cover the main functionality or explain how the system is going to work. You can use mock applications for this or simple animations. There are lots of tools available nowadays for quickly constructing prototypes and mock applications, so use them. Finally, you need to negotiate with your customer to get a sensible set of requirements that you can guarantee to deliver on time within the proposed budget. You may also need to resolve conflicts between stakeholders. For example, end users want a minimalistic interface, but the CEO of the company is in love with skeuomorphic interfaces. So how do you practically incorporate requirements engineering into UP? Here's an example. In the exception phase, you could start with a 2-day workshop to make an inventory of all the use cases, and you write a brief description of them. In the elaboration phase, you create fully dressed use cases and discuss them with the client. You can then continue to design the architectural foundation and start implementing prototypes. In each following iteration, you further develop use cases and check them with the client. We covered the process today of putting together requirements of a complex software system. Requirements engineering fits well in UP, but you can also use aspects of it in Scrum. For example, by filling the product backlog with the requirements that you collect. To find out what the customer wants, write use cases or user stories depending on the process you follow. This concludes the clip about requirements engineering. If you have any questions, let me know by posting them in the Teams channel of this course. Thanks for watching and catch you in the next one.